Today I'm reacting to the AWS data infrastructure at Orange Theory Fitness, where they are measuring the fitness data from wristbands, from their customers, and also from the training machines. I think it's a really cool use case with a lot of data from apps and from the machines and from the users. So let's look at it. Okay, so what they have is they have mobile apps, and they have stuff that is within the fitness studio. For instance, they have the wristbands, or they have tablets that are mounted on the machines and connected to the machines. And then they have a server within these fitness studios that actually then communicates with the cloud. It's pretty nice because these things here don't actually need to talk directly to the cloud. They have a intermediate step, and the app can actually then talk directly to the cloud because it's on the mobile network.
We also have our fitness equipment, which are equipped with our own tablets, which we've designed and built. And both of those are collecting data as the workouts go. So all of that data goes into a local machine that aggregates it. It also serves as a resiliency point because the studios need to be able to work even if they lose connectivity to our backends.
Yeah, so that's something that is important. As I said, it's good that they have this machine, because let's say the cloud goes down, or the cloud connection goes down. You want to have people do their workout just as if nothing has happened. Otherwise, you would run into problems that people who are actually doing the workout cannot do something. Or the data will not get monitored and will get lost. You don't want that. You want to have a machine like this. Yeah.
To my cell phone.
Right. So this computer that I mentioned, which is gathering all of the information as the class is ongoing, will also communicate to API Gateway and authenticating using Cognito. Right. So we use Cognito for both authenticating the studio computers as well as authenticating the member on their mobile app.
It's very nice to actually do it this way, because using an API here and using a service for authentication, this allows you to use the same pathways for both for apps and for the local studio equipment, which makes it easier to actually manage everything. It's really, that's a nice idea.
Right. So the data flows, whether it's an in-studio or out-of-studio workout, flows through API Gateway, and then flows through our Lambdas or our EC2 and then gets stored in our databases. There's also second-by-second telemetry.
In this is a super use case for APIs, and understand how important APIs are. As you can see here, everything flows basically through the central API gateway. And this is a really good use case. Of course, they have Firehose here, so we're going to see most likely that this thing is actually writing data into the Firehose. But for statistics data, let's hear what he says about the statistics data.
Telemetry that we are able to send through Kinesis Firehose and ultimately land again in our data lake.
Okay, so the telemetry data is going to go through.
Wind up putting all that member data into our data stores. And then the member is able to authenticate, look up the class, and see their results, whether in or out of studio.
So we have both the studio components and the mobile components. How does Cognito integrate with those?
So the member has a single account across all of our environments. So they can log into the mobile app as well as our soon-to-be available OT Live environment using their Cognito authentication.
Yeah, so you see, that's what I meant before, that you have the same, because you have the same mechanism for this equipment and for this equipment. You can actually then use the same pathways of interacting with your platform, interacting with sending in the data. So that is really cool. And as they said, the telemetry data, they're going to send the telemetry data then directly into a data lake or into the backend. All right, so this setup here with the databases behind and the processing, this is pretty rough, right? This is just the overall thing. And the cool thing is, again, this shows you how APIs and API Gateway comes into play here. They are the central point where you interact with your platform. So let's look at a bit more details. This is another part of this video.
Well, I've always been really passionate about data and how it can be leveraged as an asset for an organization. So this was really an attractive opportunity for me. When I met with our CTO, Joe, initially, he basically showed me a blank whiteboard and he said, here's where we're at now. He then showed me the 5-year plan and the vision from our senior leadership team, and it excited me.
That's the cool part. Always, when you start a project where you can go from zero and where you start on a clean slate and can build and just use the best solutions that fit. So that's really cool. I admire him. It's nice to start this way.
And he said, this is what you're going to help us do. So needless to say, I said, sign me up. You know, we got to work quickly. We built.
Okay, let's move forward.
What you're looking at here on the left.
Again, here now you see this is a bit more detailed. On the left here, this is where the APIs are coming into play, right? And this is the Lambda that sits behind the API. Where, for instance, if you use API Gateway, this is where this is the Lambda connected to the API or to the APIs. If you have multiple APIs and multiple Lambda functions. Then we have the data storage layer here, basically with a relational database, with a NoSQL database, and S3, which I would say is the data lake. And then we have the streaming Kinesis Firehose that we saw earlier in the earlier video. And we have something behind. Most likely that's a relational database or whatever they have in here. Let's see.
Is our application layer. So within this, we have a few third-party integrations for critical systems. We also have several in-house platforms that do a lot of essential functions. All of the communication into Orange Theory down to our data layer goes through Lambda API calls.
And that's what he meant, Lambda API calls, because here in front of it is API Gateway, and this is the Lambda, or these are the Lambdas that belong to API Gateway.
What you're looking at here would be the interface between here and our data layer. So these are our different and various data stores where we house our data.
So in this data layer here,
Kinesis is not really a data layer or a data store. Kinesis is just for sending stuff through.
I see several different database options. Can you walk me through what those are doing?
Sure. We're leveraging Aurora RDS MySQL for our transactional data layer. So that has a lot of common data points, member profiles, classes, studios.
Again, that's why they took this here, a relational database. It's very classes and so on. This is very structured data, and you want to use a structured approach to this. That's why this is there, and for booking of the classes and everything, member profiles, whatever.
DynamoDB, we're using a NoSQL solution for our hot data. This is things like performance data, workout statistics, things that we need to be able to get back to our apps very quickly.
Yeah, so statistics, measurements, that's all in the DynamoDB layer. So you can already see this here. They basically split it this way. This here is very structured. This here are like performance measurement data. This is a lot more unstructured data. That's why they chose DynamoDB as a document store here, where you then just put in the data, and most likely the API, the app is going to talk with this, and it's going to talk with this. This here, the above with Aurora for, like when you log into the app, or when you change in your user profile, or when you book a session, and then once you want to look at your performance from the training session, this then uses DynamoDB. But you don't see this. It's all just on the app, the interface behind it. You don't know. And of course, this is not direct connection, but it's going through the lambdas and the API gateway. So I should draw this more like this. This part here, this way. Yeah.
So what design considerations led you to choose both types of databases instead of just choosing one?
So we're firm believers in the right tool for the job. So for us,
Okay, I need to stop here because this is important. The right tool for the job. This is also something that I say to my student all the time. You need to want to use the right tool for the job. You don't want to go overpowered and use a NoSQL database whenever you don't need it, for instance. And that's what they basically did. They have the relational database because they know this is exactly the right tool for the job. And they have then their other things because these are for the job of these, for these other jobs, the right things. So always keep this in mind. Personally, I always start by looking into a relational database design. Okay, if I want to build this or if I want to design this in a relational database, how would that look? Where would the problems be? And what type of tools or technologies can solve these issues? And that's where you then go ahead, and that's when you then maybe make the decision to go with the NoSQL database.
Plus, we had a lot of dynamic use cases, so we didn't select one single technology solution. We figured out a way to pair the best possible combinations of things together. So DynamoDB for our document storage, really fast performing data that you need to get back through to the apps and API calls. Absolutely. Data at rest or data that's shared across platforms that needs to be in sync. We went with the Aurora RDS mice.
It needs to be in sync. This is one important part because this is a transactional data store, right? This is OLTP, and this is where whenever they communicate with this and whenever they send data to it, they are going to make sure that they're going to open a database transaction, they're going to write data to it. Maybe very often you need to add data to a few tables, and then you close or you commit the transaction, and either it commits or it rolls back and you would on the app get an error. It's very important to understand this, that's where the relational databases actually shine.
MySQL. For the second-by-second telemetry, it's really a lot of data. So this second-by-second data streams in near real time through Kinesis Firehose, and we're landing that into the S3. We have a traditional data lake pattern there, different buckets for different things. That goes in a raw format. We can.
That's when you use something like Kinesis. You don't want to, if you're streaming a lot of data and you have this connection, remember on the left here, this is where before we had this local workstation, local server, local machine within the fitness studio. It has direct access to the Firehose, and where you send in a lot of data, like the raw data. And you don't want to drop this into DynamoDB because it will be a lot too much, and DynamoDB will cost a lot of money. The write performance and read performance needs to scale up, and then it's super expensive. You don't want to put this into a relational database here. So you go this route to actually store the raw data to later then process again. So that's why they use Firehose, and also because once configured, Firehose is automatically going to drop this into S3 as a file. You don't have to do some manual transformation, or you don't have to configure transformations for it. It's just going to go. By the way, that's also what I did in my AWS course. I showed how to use Firehose and write data into Firehose from a producer and then write the data into S3. What I also added was I had here Redshift, and I showed how you can use Firehose to actually drop data directly into Redshift as well. So it's really cool. Firehose is a super powerful tool to automate these kind of processes, these kind of data droppings.
Can then later process that down the line in many various ways to data warehouses and other analytics data stores.
Yeah, you see, this is the data warehouse part, and most likely they are going to have their BI tools here that are then connected to this part where you then run analytics, or if you want to run machine learning, either run this here or use the machine learning, the S3 data. You could do a cycle like this. The machine learning actually takes the data. Machine learning actually takes the data from S3 and then analyze it and drops it into the data warehouse.
Also, we push up a summarized version of that telemetry. So after each workout, you get a summary of what you did. We have the history of what you've done in the past, and that's what is readily available in DynamoDB to be called back to the apps.
That's what I meant, is that the data from here is too big to actually fully go into DynamoDB. It's big enough, or it works through Kinesis and to S3, but actually going directly into DynamoDB is way too much. That's why they are doing aggregations of the data. Like you're doing the training, and then you get a overview of the training, not just all the data points.
So when I check my phone after a class and I see that I've earned so many splat points, where does that data come from here?
So the data for that is actually coming from DynamoDB, reading directly back to the mobile app.
Well, the arrow is wrong here, right? The arrow should go this way, or better drawn, should actually go this way, right? But you get the point. This is why they use DynamoDB here. It's very quick. You can query the data very, very, very fast, not just like with a relational database, or it would be very problematic to actually take all that data and store it into the relational database. It's a one quick call without needing to create joins or whatever. Very cool.
Basically, we aggregate those statistics directly after a class and push those into that hot storage so that it's readily available the second it hits the database.
Then what's coming from the Aurora right there?
So Aurora is used to house the common supporting data for the mobile app. This is where we would have your member profile, the studio and class information for you to book into, and your membership purchase history.
All the super structured data, it's all there. It's in the Aurora DB. The hot data, as they call it, and the overviews, they're in Dynamo because it's very fast and very nice to actually deliver this. You can store this as documents, and then you have your Firehose that actually takes the raw data, streams the raw data through it, and pushes it up into S3. Super cool.
Is your data store here?
So we definitely wanted to take a data lake approach to putting all of our data together. S3 was extremely lucrative for us because it's very durable, it's very economical, and you really can store a lot of data there. We're pumping data from Aurora into that. Obviously, what I mentioned earlier through Kinesis Firehose, which is probably our biggest data set, but we also plug in a lot of third-party integrations into S3. So really, as you can see, it's really a hub for joining all the data together, and it's very seamless and easy to plug it into all areas of our applications.
Yeah, that's where what is nice here is as you see, he actually wrote it here. Very often what you have is the data, you have third-party providers. This could be something like Salesforce or Google Analytics or something, right? And these things, they will give you files. They will not send you APIs, or they will not send you data. You will request the data, or this data will be dropped somewhere, and then you would actually then just push this into S3 and process it. It's very good, very good. Yeah, and this basically this aggregated data, you don't actually need this here because you already have the raw data, so you can generate this from here anytime. Yeah, and as I said, if you want to run ML or some kind of analytics, you would actually use this data and then write this here. I think they built it really, really well. The only thing that they didn't show is what they're doing here on the right side. If they are building stuff with the data warehouse, if they're using here Redshift, what they're dropping here in the bottom. And if you're thinking about machine learning, like what are they doing here? Are they taking the data from S3 and then dropping the results into the data warehouse? Do they have here BI tools that actually then connect to the data warehouse and visualize the data and help explore the data? Does the machine learning also take results and stores them, for instance, here in DynamoDB, where you could do some more aggregation, some more insights, some helper, some tips for people like you're in this bracket in your age group, whatever. I think that's all possible. As I said, super cool use case. Thanks for watching. Let me know in the comments what you think about this, where you might would do something different, or if you have some questions around this and that I can answer more. Check out the links below. I put the video, the base video, in the links. I also put the link to my Data Engineering Academy at learndataengineering.com, and then see you in the next video.